Okay, we're back. What were we doing? We were about to look at the cluster demographics. We already did all this. Yeah. So we just made our validation data set. So we're going to run this little line here, which is taking rows 2 through 5, or variables 2 through 5. So that's online, work, cost, and flex. And it's going to list them by the cluster number that they were assigned to, and it's going to give us means. Cool, so we can look at the differences between those, at least eyeball them. I just moved this line, but I don't think it matters. Let's run it. Boom. Control Enter to run. Cool, so now we see we got cluster 1 and cluster 2, and the differences in the means between these two things. So it looks like cluster 1 kind of falling into our profile. High in work, high in cost, and pretty high in flex. Whereas cluster 2 is lower in work, lower in cost, and it's higher in flex, so not perfect. And just eyeballing it, we can see it's just a little bit higher, whereas these are considerably higher. And in terms of online, our cluster 1 is the one that is higher in online, but we don't know if that's statistically significant quite yet, but we can find out through t-tests. So I've got our array of t-tests here. Let's go ahead and just run this first one to see if there's a statistical difference in these two means, to see if one cluster is more likely to win online courses. Boom, t-test. Means 1. Oh yeah, and Steven, I'm going to just tell you this in the video. You're doing t-test wrong, man. That's why you're getting weird means, and you're like, oh, just ignore that mean. It's just comparing the mean of one thing to the other thing. That's because you were doing it wrong. You weren't looking at this as a grouping variable. You were just comparing the mean of this to the mean of this, and so that's what your t-values and p-values were talking about, and that's why I said group X, because group X, when you did it the way you did it, it just takes X and compares it to Y. So in the way I'm doing it, looks at this as a grouping variable. So we have group 1 and group 2. And the means reflect what we see right here. Cool. I don't know if I'm supposed to call you out or if this is supposed to be for like general use, but I did it, so fight me. But yeah, so this is how we do that the t-test. The variable of interest, and then the grouping variable, or the variable of interest tilde, the grouping variable tilde, tilde, tilde. I love tildes, tilde, tilde. Okay. Cool. Anyway, what were we saying? Oh yeah, significance totally is p-value less than 0.05. Sweet. So group 1 looking like it's a winner. And sure, we can go ahead and run these t-tests too, just to see. So what these are going to tell us, this was like, hey, is there even a difference in the outcome variable we cared about? Looks like yeah, and significantly, and marginally. Not 0.4 points. Like, that's fine. Cool. Is a difference, is probably a practical difference. Not super big though. But so we can also look at did these differences matter? So basically, were these significant in the clustering process? So we'll run all three of them. I have them highlighted, so I'm going to control enter. Wing up at 7:30. That's not exactly right, but sure. Yeah, it took 30 minutes for that video to upload, as you can see, because the last one said 8.5. Okay. Damn, that means I only have 30 minutes left. Okay, we're gonna speed on through then. Hopefully this gets uploaded in time. Cool, we're gonna scroll back up. Yeah. So this is our first one that we did. Work was significant, super duper low P. Cool, we expected that. and I guess I shouldn't say that, but these are really big differences. These are also pretty big differences. Was significant? Yes. Cool. So these were both factors in the clustering. And the last one is also significant. So despite it being small differences in the means, only like a point, less than a 0.3 difference. These were significant differences in the means. So not exactly the split we want to see. Now we want to see all high and all lower, but pretty good. And pretty good in the fact that online was statistically different. Surprising though to see that group 1 was a little bit lower in flexibility. Anyway, let's look at what would have happened if we went with a 4 cluster solution real quick, and then I'll bring us home with some box plots just for fun. Or I guess not really just for fun, but to kind of understand the distribution a little bit more. But yeah, remember when I made this magical number 2? What if it was 4? Certainly it's a 4. No one can prove that's not a 4. 4 is the perfect number for this. Okay. Let's run literally everything again. So we're gonna have to rerun this because that MCN kind of determines, or definitely it determines how many clusters we have. So we'll run that the whole cluster, the actual hierarchical cluster analysis again, and then we'll also push all of that into this valid again because we need to get a new variable for groups. All of these will all stay the same. Control enter. Oh, that's kind of weird. Why is it doing that like that? That is weird. Okay. So it popped up the dendrogram on the side of the old dendrogram, which is weird. Kind of like I alluded to earlier, though. We could already see the split is now like these prongs and these prongs. So yeah, we pretty much already saw this. All this did was change where the boxes were. Kind of helpful, but whatever. What we're really interested in is how do these differences work, and so t-tests aren't going to work anymore because we have got 4 groups. So let's run our means again. Control enter. Cool. So yeah, now you see we have 4 groups because we chose 4 as the amount of clusters, and now we have means for each different one. So we do have a cluster 1, that is high in everything, and it also has the highest online, which is interesting. So maybe we might want to go with this 4 cluster. Actually, we'll look at it a little bit more to find out. Because if this is meaningfully different from all of these, statistically different, it might be a better solution since it kind of goes with our story of we think that people high in this might be more likely to attend. So then we have people in cluster 2 who are like higher in cost and flex but lower in work. We have people in cluster 3 who are only high in flex, lower in work and cost. And then we have these people who are in 4 who are opposite from 3. They're high in work and cost, lower in flex. They're the only people who are low in flex too. That's kind of interesting. That's just descriptive. Let's see what's up in terms of statistical significance. So I have these commented out right now because this, spoiler alert, we're going to go with a 2-factor solution. But I'm going to go ahead and uncomment these by control shift C'ing and run them by control entering, and then go ahead and control shift C them again so I don't accidentally run them again. But what these do is they're going to run pairwise t-test. So they're just going to pop out significance values for each pair of groups for each grouping variable and for online. So we have, and we can just refer to the means in this table up here. So really what I'm interested in is online. here's our tables. So these are p-values. None of these are lower than 0.05 except for this one, which is the differences between cluster 1 and cluster 3. Cluster 1 was the highest one, cluster 3 is the lowest one. Everything else is not statistically different from each other, and that is pretty much why I decided to go with cluster 2 instead, because if ultimately we can't really tell the difference between if these people are choosing online classes or not, then it's not super useful to us. So that's what I decided to go with, was 2. But we can also look at these pairwises. It looks like in general work was significant for depending on the clusters, or for the clustering. It wasn't different from 1 and 4. We got cost here, kind of same story except 1 and 2, 2 and 4. And so kind of how this works is that like this is kind of explaining the same thing. These are just how the clusters are differing. Like 2 and 4 are the same statistically speaking on cost, but they are statistically different regarding work. So since it's 3 dimensions, they can differ on any other dimensions. And then flexibility is kind of interesting to see because it didn't look like there was much difference when you're just eyeballing it in the means. It looked like this one was the only one that was like low, and these are all relatively high, but statistically speaking, the only ones that weren't different were 1 and 2. So that was interesting to look at, but yeah, just wanted to show that. I don't know, like I think picking number of clusters is kind of nebulous. So we definitely could have picked 4 clusters and gone with that, but ultimately, since our outcome variable was only significant across 2 of the clusters, it didn't seem like it was worth looking at when we could just look at the 2 clusters that had differences, since that's what we really care about. But just wanted to show that off. Anyway, so let's go back. Let me reset my magical number to 2 and rerun this stuff just to get all my variables straight. I don't need to rerun all of these lines. Most of these lines are just doing redundant stuff at this point, but I'm going to do it just to make sure I have everything straight. And we'll get another ninjagram. Awesome. And I don't remember if I went over these t-tests for this analysis yet, so let's do that real quickly. No, I definitely did, right? All of them were significant. Yeah, significant. I don't think I did, but you just saw really quickly that no, I did. Okay, I already did that. We're going to do box plots now. Cool. Box plots are just going to show us more visually what I just said. They're going to show us the distributions. We're going to have one for online and for each clustering variable. Cool. Here's our first one. This is online. So the distribution is not that different, but you can see the means. So this one was just slightly more centered on the higher, but the distribution was really similar. So, statistically different, but not as big as a difference as we would kind of want to see. Because the mean differences aren't that big, even though it's statistically significant. But this kind of gives you, these are kind of cool to look at least, even if our result wasn't super promising. It shows you how it clustered things. So like this average is super different. Yeah, I guess this, you got like some outliers here. I guess nothing really represents the average here, but a lot of 5s in group 1, there's a lot of 3s in group 2, and just completely different ranges, really, of what we saw in work barrier. Cost, not exactly the same. We have a really normal distribution across this group 2 and a really skewed towards 5 distribution here for cost. And then finally, flex